Okay, hello, this is Mr. Berger here talking to you a little bit about static electricity. And we're going to start our conversation about static electricity with a little video to see an application, a pretty extreme application of static electricity. So, very clearly this is a woman who was not careful when she filled up her gas tank. With the video, take a few minutes to go back and forth a few times and take a look at what she does. And you'll notice right before she fills up her gas tank, she's kind of rubbing her sweater, and this is part of the reason it causes a problem. So what we want to investigate is to think about this example and some of the others you did in the lab the other day to try to understand how they work. So we're going to continue with some basic statements that kind of we figured out with the FET simulation that we did the other day. And you should get these down in your notes, but if atoms have more protons than electrons, they're positively charged. If atoms have more electrons than protons, then they're negatively charged. Okay, so basically that's the mechanism that which we get these positive and negative charges, which are really just a definition. Something is positive or negative. Okay. It's also important to remember, and you should write this down, that electrons are on the outside of the atom. Remember, the protons and the neutrons are buried inside. So the electrons are the only ones that can move. The protons and the neutrons are so tucked in the middle of the nucleus that they can't really do anything. So whenever we're talking about a change in charge, we're really just talking about electrons. Now, what is static electricity? Static electricity is a tiny imbalance, basically, in either positive or negative charges. And when you get that imbalance on an object, like a balloon, you get static electricity. And it's that imbalance that leads to the phenomenon, the examples that we saw in the lab, and even the example that you saw in the video. Okay, so this is just a simple example. We've got two objects here, okay? And the question is, which one has static charge? Which one is neutrally charged? And so if you could imagine that we can look into this object and count the number of protons and electrons, which we can't, of course, do, we get, here we've got 8 negative charges, electrons, and 8 positive charges. Okay, so this one has an equal number of negative and positive charges. This one, if you notice, we've got only 6 positive charges and 10 negative charges. So this one here, object B, is negatively charged. Object A is neutral. Okay, so we can get these charges either way by having either too many electrons or too few electrons. But again, the important thing to remember when you're looking at static electricity is that only the electrons can change. Okay. So, a couple of the rules. Light charged objects repel. What does that mean? If you've got one object that's positive and another object that's positive, then those two objects are going to want to get apart from each other. If you've got one object that's negative and another object that's negative, then those objects are going to want to attract. And this is something you definitely want to get down in your notes. If they are oppositely charged, one's negative and one's positive, then those objects attract. And if you noticed from the labs, almost all of the examples showed objects that were getting pulled toward each other. So we've got to think about that. It's our evidence that something must be creating opposite charged objects. Okay? A few other rules to look at. Only electrons move. Now, I said that once, but it's important, worth repeating. Protons, we can't change the number of positive charges. We can only change the number of negative charges. Item 2. Because electrons are both negatively charged, they try to move as far away from other electrons as possible. Okay? They repel each other. They push each other away. And then, of course, an object with an unequal number has a static charge. There's some review here, but you definitely want to add the important ideas if you haven't repeated them. Okay, so let's look at an example that you did in your lab. If you remember the lab, this is the electroscope station. Okay, and with the electroscope, we put an object, in our case a balloon, but imagine like a stick or a charged rod near that electroscope. And this particular object is going to be negatively charged. So, what's happening? Okay, if you remember, if this is negatively charged, this plate here has a mix of negative charges and positive charges. So what's happening is that all of the electrons that are in here are going to want to get away from that negatively charged rod over there. So what's happening is that my electrons are going to be starting to move down. So I always like to write electrons move. And I would definitely write this example down in your notes. Okay, and if my electrons move, what's going to happen is that this stem is going to become more negative down here. Okay, all of the electrons from the plate are moving down. So up here, we're going to get a concentration of positive charges. There might be some down here. But essentially what's happening is we're creating a positive and negative charged stem. And then if you remember from the lab, what happened was we had a straw, and that straw gets pushed away by the charged rod. Essentially, the straw is neutral, so all of those positive charges are going to get pushed away here, and the electrons are going to want to flee there. So it's going to do enough to kind of push the straw so that it moves. And then when you put your finger on it, what actually happens is you draw some electrons that actually go into your finger and actually will permanently charge this, and that's what leaves the straw out. So really what's happening is that your electrons are moving away from the rod, and we're leaving a positively charged electroscope, which is what causes that straw to move. Okay, let's look at another example. This is the classic balloon on the wall. What I'd like you to do is, again, write this in your notes, and we're going to imagine that that balloon is negatively charged. In reality, we don't know whether it's negatively charged or positively charged, but it doesn't matter. Okay, so what happens is we take this negatively charged balloon near the wall, and all of those negative charges are going to try to get away, as it were, from the balloon. So I'm going to move them up here. And then what's left is a cluster of positive charges. Okay, all of our electrons now are moving away from the balloon, and we're left with some positively charged. So now we have a negatively charged balloon and a positively charged wall, and that's what causes the balloon to stick to the wall. Okay, you get the negative charged and the positive charge. Okay, simple example. Now, On the opposite page in your notes, on page 38, what I want you to try to do now is show me what happens if you have a positively charged balloon. See if you can take a few minutes, pause the video, and try to guess as to how, or think about and reason out how this might work. You should get the same result. The balloon should still stick, but the charge configuration will be a little different. So pause the video. Okay, hopefully you've tried this out on your own. So let's look at this example. In this case, we have our wall, which is going to be a mix of positive and negative charges. What's going to happen is all of the electrons are going to want to get closer to that positively charged balloon. Okay, they're attracted by it. So they kind of build up here. And then what's left behind are our positive charges. Our electrons have moved here. And so again, now we've got a positive charge and a negative charge. Okay, these are our basics of static electricity. Now I want to show you one more example. This is an effect simulation of static electricity. Okay, this is the classic John voltage. Okay, what's going to happen is John voltage is going to rub his feet on the floor, just like you might. And what you'll notice are we've got these negatively charged electrons that are flowing through. And generally, this charging happens through friction. The process of friction causes some charges. Watch what's happening to those electrons. They kind of sit there. If I shake it up more, they start to do what in his body? They start to spread out. Okay. And what we have here is a metal doorway. Metal is like a superhighway to electrons. They want to go to metal because they can get away from each other really quickly. So eventually, John voltage puts his hand to unlock the door, and he gets shocked because all of those electrons are flowing through his body out to the doorknob. So we can do it again. And it happened by him getting close, but if we keep going, it will happen on its own. Okay, well, thank you for your attention. Make sure you get those notes added to your notebook, and we'll continue now as a class looking at the Van de Graaff, another example of static electricity.